Right, Matrix, let's have a look at some more examples quickly. I'm going to take an example one. Very, very useful little examples for preparing you for an exam in Matric. Number A, now be careful of this one. It's a little bit of an identity here. It says an identity you've got to prove. Now, careful with this, that sine of 45 degrees plus theta. This is actually off a Matric exam paper. Sine of 45 degrees minus theta, that actually equals a half cos 2 theta. Now I'm going to start off with the left side because I think that's pretty tricky. Okay, the left. Okay, so the left hand side is going to be the sine of 45 plus theta, and that's going to be multiplied by the sine of 45. The only way around this is to use the formulas for sine A plus B and sine A minus B. So let's have a look here. Sine A plus B, if you use that formula for the formula sheet, is sine A cos B plus cos A sine of B. Okay, then we're going to, now this is being multiplied by, we don't have space here, but I'm just going to put it at the bottom here, multiplied by the sine of A minus B is the sine of A cos of B minus the cos of A, the sine of theta, or B there. Okay, alright, in this case, now if we look at this, this is going to give us sine of 45 is root 2 over 2 special angle cos theta plus cos of 45 root 2, you know that by now, sine theta, and this is all going to be multiplied by the sine of 45 is root 2 over 2 cos minus root 2 over 2 sine. Okay, now if we look at this, we could probably take out a common factor. I think maybe if we haul out a common factor of in the first brackets of root 2 over 2, and that gives you cos theta plus the sine. Okay, and if we do the same here, multiply by, take out the root 2 over 2 there, and we're left with cos theta minus sine theta there. Okay, and if we combine that, a root 2 and a root 2 is 2, 2 times 2 is 4, and we're left with cos plus sine over cos minus sine there. Okay. Good. Okay, so 2 over 4, that's the same as a half. Great, that's almost what you wanted. And then this is a difference of 2 squares, so it's cos times cos is cos squared. You just have to multiply out cos times cos. Cos times sine and minus sine is minus sine, plus the sine cos vanishes, and then you're left with minus sine squared theta there. And what do we know about cos squared minus sine squared? Well, that's the formula for cos 2 theta, and have a look at that. Lovely Matric exam question. It's exactly what you wanted to prove there. Okay, so apply the, just multiply, expand those little sine A's plus B's, or 45 plus theta, 45 minus, and then do that whole thing, and look what it does. It comes out with, and then you use your special angles. They love that there, and then you simply take out the common factor, quite easy to do, and then connect those two, multiply those and those, and then you can multiply, expand that out, and you're left with cos squared minus sine squared is cos 2 theta. Okay, now what we've got, and I'm just going to write down in the B part, we've just proven that sine 45 degrees plus theta multiplied by sine 45 minus theta, that mess is equal to a half cos 2 theta. We've just proved it. Now, what they do is they'll say to you, they often use the word hence. They'll hence, what they want you to work out is sine 75 multiplied by sine 15. They want you to use the hence means use this identity at the top here that you just proved. Sine 45 plus theta, sine 45 minus theta is equal to a half cos 2 theta. Use that to answer this. Well, look at this, where there's a sine and a sine, and then we've got a 75 and a 15. Now, if we take the left side, if you think of it, can we express the left as 45 plus something? Okay, what could theta be? Well, if you make theta as 30, okay, look at that, that's still 75. If we then do exactly the same, but we say 45 minus something, which again is 30, Look at that. There's theta again. Then the answer to this will be, so in other words, you've got sine 75 sine 15 is equal to sine 45 plus 30, sine 45 minus 30, using that. But that is equal, because we've already proved it, equals to a half the sine or cos of 2 multiplied by the theta. Look at that. You see that there? 2 times the theta there. Okay, and that's wonderful, because then we can say that this is a half cos of 60. And if we go to our special angles, or in fact just cheat on a calculator, we find that the cos of 60 is of course a half, and that's adjacent over hypotenuse, and so your final answer will come to 1 over 4. Good. Okay, should we look at a second example quickly, which is a very nice one. These are so important for exam purposes, and it's worthwhile as a matriculant to go through. How about this one? Rewrite the cos, now not double but a triple angle, in terms of cos theta. That means simply this cos 3 theta must be written as something that's just got thetas in and not 3 theta. And we want to now work with that. But that's actually very simple, because all you do is you split it up, okay, into a compound angle. In other words, cos of that would be cos of theta of 2 theta plus theta. You can do that, okay. 2 theta plus theta is 3 theta. Now that's a cos A plus B. Now if we go to our formula sheet with the top there, cos A plus B is the cos of that A, which is 2 theta, cos of the theta, minus the sine of 2 theta, sine of theta. That is your compound angle formulas. Now look at this. Now the only problem is, okay, we've got our, these two are fine, but this is a problem here. Still got a double angle. That's a double angle. We want to get rid of that. And it's got to be all in terms of cos. So what I could do for this one is, of the 3, it's probably advisable to go for 2 cos squared theta minus 1. That's already in terms of cos. Multiplied by cos, of course, there's nothing you can do with this one except make it 2 sine cos, which is not too bad. And then we're left with sine theta there. Okay. Alright, sine and sine is sine squared, so let's distribute. So if we take that times that and that times that, we get 2 cos cubed theta minus 1 cos theta. This gives us minus 2 cos theta there, but then we're still multiplying by 2 sine squared if you connect these two sine squared. So there's all coses except this chap here. And what do we do with that? Okay, well, simply put, do you remember that sine squared theta plus cos squared theta is 1? So if you want sine squared on its own, all you do is you bring that to the other side. So it's 1 minus cos squared. So that's beautiful, because now we can write 2 cos cubed theta minus cos theta, subtract 2 cos theta into, and this is going to be quite fun, if we just bring it right across, into 1 minus cos squared theta. And that, of course, is all in terms of cos, so no problem. We can then multiply out. So let's do a distribution. So it's minus 2 cos theta plus 2 cos cubed theta if you times that out. And then 2 of those plus 2 of those gives you 4 cos cubed theta. And this gives you this minus 1 minus 2 is minus 3 cos theta. And there's your answer. You've expressed cos 3 theta in terms of theta. That's quite a nice little nifty identity for cos 3 theta. Don't learn it, but it is quite useful. Okay, let's have a look at another example quickly, guys. Identities. So this would be a third example quickly. And they often ask this, linking to compound and double angles. You've got to prove, now watch this, that 1 minus cos 2x minus sine x divided by the sine of 2x minus cos x, you've got to prove that that equals the tan of x. Okay, alright, now what I'm going to suggest you do is, let's start with the left side. So we're going to prove it that, so I'm going to just remove that right side there, and I'm going to start by saying that let's equal. Okay, now the thing with this cos 2x here, there's 3 formulas. You could literally use any of them, but I'm going to suggest sine 2x is pretty easy, so there's no problem with him. But with this one, I'm going to suggest that we go 1 minus 2 sine squared x. There's a reason for that. And then we subtract sine x there. The bottom one is going to simply be 2 sine x cos, because that's the only formula you have for that. Okay, but the reason for this guy here is because notice when you multiply out, what's going to happen? Now, of course, you could use the other formulas, but the reason why this is brilliant, because you have this situation. If you multiply out, you've got a brilliant situation here. The ones cancelled. You see that there? And that's really the aim of this whole thing, to get those ones to cancel. Okay, now all you have to do is the ones are gone, which is absolutely wonderful. And if they vanish, we've got this thing at the top here, 2 sine squared x minus sine x. And at the bottom, we've got 2 sine x cos x minus cos x. Now, all you need to do is apply the techniques of factorization. Remember, if you had, say, 2a squared minus a, you take out an a and you're left with 2a minus 1. Now, we're going to do exactly the same thing for this top one here. Okay, and the bottom one, as a matter of fact. Okay, so here we go. Okay, equals, take out the sine x, it's common. You're left with 2 sine squared x minus 1. Okay, factorizing as you did in earlier years. In fact, that 2 shouldn't be there. It's just sine x there. Okay, so let's fix it up there. Sine x there. Great. Let's check it. 2 sine squared minus sine. There's a common cos in there, so let's take out that. And you're left with 2 sine x minus 1. And of course, that's brilliant because these guys cancel. Okay, so that equals, now sine over cos, what do you know about that? That is actually tan x. And there we go. What a pleasure.